Thank you very much for that introduction. I'm aware we are starting a little late, but we'll try and make up and keep to the timeline for this session. Air Chief Marshal Bhadoria, former chiefs, Air Marshal Golani, DG CAPS, Major General Arora, editor of IMR, distinguished veterans, my colleagues in uniform, and partners from the industry. The topic for this session today is emerging technologies and industry capability, which is a wide-ranging one. And it is within the overall ambit of air and missile defense as part of this seminar that we will address this topic today. To discuss this topic, we have a very, very well qualified panel. We have representatives from the practitioners, representatives from the field. We have experts in communication, experts in cyber who will give their perspective, as well as innovators and creators in the field of counter-drone technology. I'm very confident with such a distinguished panel, the quality of discourse will be indeed valuable for us today. We saw the opening session in which several remarks were made, and just to put the session in perspective, I will give a few points that you may consider, which we will doubtless address during both the talks from the speakers as well as the Q&A session. So the current threat landscape was touched upon by more than one speaker, and with the evolving threats in both missile and air defense, that is improvements in sensors, improvements in weapons, the proliferation of UAS, all these were talked about, and they are real, clear and present dangers today. We also need to add that our paradigm has changed to include not just state-on-state threats, but also the very real threat in this domain from non-state actors. As I see it, there have been in this field two fundamental revolutions in the past. The first was a revolution of sensors, in which radars were used for the first time to accurately guide anti-aircraft shells to their targets. The second, of course, was a revolution in weapons, where the guided missile supplanted the air-to-air gun as a weapon of choice, thus increasing the kill probability tremendously. Today, however, we are not just in a revolution, we are in a transformative stage. And the reason I say this is that the entire domain has evolved and is evolving at a very rapid pace, which makes it difficult to catch up or overcome in only one domain. Our threat, as has been said, covers all the spectrum from hypersonic weapons all the way down to FPV drones, which is a very wide range. The defense has moved on to embrace technologies such as directed energy weapons, such as quantum radars, sensors, communications, and all of these are enmeshed in the entire system of systems that is air defense. So this aspect, of course, poses several challenges, and I'll just touch upon a few for consideration during the discussions. We talked about integration and interoperability. It was touched upon by Colonel Kuber in the morning. There is a need to seamlessly integrate your weapons, your sensors, your C2 communication, not just among the three services, but among all stakeholders. And that's not an easy ask. Legacy systems that we have to integrate, the data rates, are all very, very difficult considerations. The AD Commander mentioned that we have done so successfully in the IACCS. It's a tremendous achievement, but as we integrate more and more new systems, the challenges continue to multiply. We have strategic challenges in this sector. We have to detect, track, identify unambiguously hypersonic weapons, all the way down to detect, identify, and ascertain the threat perception for swarm drones in civilian areas, in high-value target areas like central Delhi. It's a very wide-ranging ask. The moment you try and put it all together in one single integrated air defense system, the challenge gets real. Operational effectiveness, I think every speaker talked about the real-world use cases. So I think we moved out of theory today. We have case studies from the Houthis attacking shipping, Houthi is attacking Iran, Houthi is attacking Israel. They are attacking refineries in Saudi Arabia. They are attacking airports in Abu Dhabi at ranges of thousands of kilometers, non-state actor. The Chinese balloons over continental US initially proved to be a very tough nut to crack for US air defense, which is considered one of the best in the world. We have Hamas, Hezbollah attacking Israel with a multitude of weapons across the spectrum, all the way down from 5-kilogram drones, all the way up to ICBMs coming from Iran. The layered nature of the Israeli air defense was touched upon, and that is something which has to be done. And of course, the talk of the hour is the full-scale conventional war which is going on in Ukraine. Force upon force, classical air defense, new technologies like drones, all of it being meshed in one unending conflict which is engaging us and occupying us today. But the only point I wish to make in this is there is no dearth of case studies, but drawing real-world lessons for us, applicable lessons for us to use in our environment is a tricky business. You draw the long lessons, you go along the wrong path, which is something we must be careful not to do. Cost and affordability is a very serious issue here. It was mentioned that the attacker in this kind of case, for him it is cheap, for the defense it is expensive, and that is true. The ability to design, develop, deploy, maintain a high-end integrated air defense network is not easy ask for any country, and not especially one which is strapped for resources. I'll give you some open source information to think about. Open source information says that the cost of a single Patriot missile is something in the region of 4 million USD. The NASAMS, which has been talked about, that AMRAAM, and the same AMRAAM which was used by the E-18 Growler, which he talked about to drown that drone, is in the region of 1 million USD. The cheapest or supposedly most cost-effective interceptor missile today, the Tamir missile on the Iron Dome, is in the region of $40,000. These are all open source figures, but we are somewhere there in that ballpark. If you're talking about an expensive DJI drone today, expensive, top of the line, it's in the region of, the top you'll go to is about $2,000. A Shahed 136 costs roughly $10,000 to $12,000 to manufacture, maybe $30,000, $40,000 to buy if you're buying it from someone else. So if you match these figures, the real risk is of saturation with low cost, which will deplete your high-end, gold-plated, good-looking IADS in no time. And what do you do next? A very real problem for the planners to think about. There is also the impact of cost of testing and simulation. Once again, not a trivial issue. How do you test against a full mass saturation attack by ballistic missiles? Very difficult to do. Is your simulation good enough? Is the fidelity good enough? Something to consider. Maybe it can come out in the questions. Future technology. Yes, future trends, future innovation can mitigate, but it can mitigate both sides. As we advance in defensive technology, the same advances of quantum, of AI, of machine learning, of automation is available to the attacker as well. It is a cat and mouse game, and as the AD commander brought out, this continues. It's like ECM, ECCM. We continue in this game with getting a one-up advantage over the other guy for a short period of time, but then the tables turn. So this is continuous and never-ending. Finally, of course, we will come to the aspect of self-reliance, strategic independence, strategic autonomy. Atmanirbhar is here to stay, and there is no question. We have to support, we have to make it within our country. That goes without saying. But to balance the need for cutting-edge technology with the real and present need for immediate capability in the field, once again, is a difficult task. We need technology which is here now proven for a practitioner to do his job and assure air defense. We need to invest in new technology and to experiment in order to develop in-house. There's a bit of a conundrum in this. If true progress in indigenization and our ability to do from within is there, there has to be an increased risk appetite from all players in the game. Both the industry as well as the user will have to, and I'm sure they are looking to, policy stimulations, policy injections to make sure that this risk is balanced, that this risk is mitigated, and development can continue in the true sense in which it has to. We'll explore all these further in the discussion and probably in Q&A. I think I've spoken enough. It's time for the speakers to get on with it. A quick word on the session administration. Each speaker gets 15 minutes to speak. I would request you to stay within that time. 2 minutes to go, I'll give you a heads up. And at 15, I'll give you an indication that we can close so that we can maintain time. After that, I will open the session to questions. I will field all questions. The speakers can answer one or more of them if they choose to. I would request the audience to please keep it to one question per questioner so that everyone can get a chance and we can widen the scope of the discussion. At the end of it, I will wrap up with whatever takeaways we can take from this session. So without further ado, may I invite our first speaker, AVM Shivanand, to please give his talk.
Thank you, Tommy. It's a wonderful table that you have laid for me to take on from here. Former Air Chief Marshal Baduria sir, DG Caps Air Marshal Golani, the Chief Editor of IMR General Arora, senior officers of the Air Force, distinguished guests, and my fellow co-panelists. It's indeed a very good morning to you all, and I feel very honored to be standing in front of you to be talking on a very important aspect of air and missile defense India 2024, and on an important and an interesting aspect of the operating environment. In the realm of air and missile defense, the operating environment is indeed a vast canvas to talk about. I say this because most of the geopolitical conflict zones or incidents in the recent past, the list is in front of you, the Aramco attacks, the Azerbaijan-Armenia conflict, the Israel-Iran skirmish, the Houthi attacks in the Red Sea, or the ongoing Russian-Ukraine conflict, involves the operating environment of air and missile defense. Hence, it's indeed a challenge to do justice to this vast topic. However, what is more important is that it is this very domain that exemplifies the character of war. And I'll dwell on this topic for the next few minutes. In a recent event to launch a publication on future of defense, the former chairman of the Joint Chiefs of Staff, General Mark Milley, said that in the next 10 to 15 years, a quarter to third of US military will comprise of robotic elements. He noted that these robots could be commanded and controlled by AI systems. He also said that the advancements in technology and changes in the character of war will enable militaries worldwide to make smarter and faster decisions. A small point he also added is in terms of the nature of the war. He said that the nature of war doesn't change much because it involves human activity and the act of politics, wherein one state is trying to impose its political will on the other by the use of organized violence. The character of war, however, which involves tactics, technologies, weapon systems, and leadership training, is bound to change. With the rise of artificial intelligence and robotics, the world is currently experiencing the biggest fundamental shifts in its history. If you look back into our own history, some of the most transformative events that have forever altered the landscape of armed conflict were the invention of gunpowder, the change from the musket to the rifle, the invention of dynamite, the invention of the airplane, and the recent emergence of drones, swarm drones, and now with the infusion of AI and robotics into its technology, especially in the exploitation of drones. So as a practitioner of air defense, in my opinion, the biggest transformative change that has happened in recent times is the fusion of AI and robotics technology in the application of drone warfare. In late April 2024, delegates from 143 countries joined activists, academics, and journalists at a meeting in Vienna in the hall of the Hofburg Imperial Palace to attend the biggest ever conference on autonomous weapon systems. As the data screen displayed digital information of the autonomous drones devastating cities with their firework, the Austrian Foreign Minister, Alexander Schallenberg, told the audience This is the Oppenheimer moment of our generation. Autonomous weapons systems will soon fill the world's battlefields. Technology is moving along with racing speed. Gentlemen, you will all agree that in the manner in which the medium of air is being exploited of late and in the current decade has undergone a transformative change. And the biggest challenge is in defending the airspace domain, or in other words, air and missile defense. As the war against Russia drags on, Ukraine is emerging as the testing ground for the cutting-edge warfare, including drones and other vehicles capable of autonomous mission execution. Drones have broadened the buffer zone between Ukraine and Russian combatants from a couple of kilometers to as much as 20 kilometers. Anything that is there in this buffer zone gets hit by drones. The conflict has also showcased the emergence of loiter munitions and hypersonic missiles. This slide depicts the entire gamut of threats in the air defense domain. They range from exo and endo-atmospheric threats to the conventional air-breathing threats to the sub-conventional threats. When viewed against the threat ladder perspective, they range from sub-conventional to the strategic. The most significant aspect is that each end of the threat ladder is expanding outwards, meaning the speed and the RCS envelopes are being expanded at both sides of the spectrum, and therein lies the biggest challenge to an AD practitioner. This is because conventional AD sensors were designed to detect within certain speed and RCS limits, which enable them to address conventional threats. Hypersonic missiles and loiter munitions have been the biggest disruptors on the design specs of these sensors, leaving the designers scrambling for designing new types of sensors to address these threats. In order to address a holistic and credible air and missile defense, one would need layered and tiered air defense sensors and shooters, and these systems would need to address this threat in a holistic manner. What are the challenges that we face? Gentlemen, the operating environment has changed the character of air and missile defense battle space. There is an increased use of non-traditional airspace like near space zone and non-commercial airspace for military as well as illegal purposes. High-altitude surveillance balloons have been spotted, tracked, and shot down over the continental United States. They have also been monitored in other parts of the world, including our own island territories. Proliferation of high-altitude long-endurance platforms and high-altitude persistent surveillance platforms, which exploit the ambiguous airspace beyond controlled airspace, is a cause of concern. Recent years have witnessed advancements in niche technologies in terms of stealth, AI/ML, quantum computing, swarming technologies, and autonomous warfare systems, along with associated advancements in air threat and the capability to gather intelligence through aerial platforms. The modern air threat is all-pervasive in nature, and it has no recognition of state borders. Emergence of drones and loiter munitions has been the biggest challenge in the AD domain due to aspects that already been brought out. While they present a unique challenge, the emergence of hypersonic weapons on the other end of the speed spectrum presents another facet of the challenge in the AD domain. The rapid growth of civil aviation in developing nations across the world is another facet that needs to be considered in the operating environment. We are all aware of the tragic shooting down of the Malaysian Airlines MH17 when overflying a conflict zone. In any conflict, the first victim has always been civil aviation. Russian jamming in Ukraine is wreaking havoc on GPS availability in Eastern Europe. Earlier this year, GPS interference forced the closure of a major civilian airport after flights had to be diverted en route. State and non-state actors are increasingly resorting to weapons since they have a reasonable measure of precision guidance and reachability to any corner of the adversary's territory. When contact battle doesn't take place, it invariably the medium of air which carries the battle to the enemy and hence entails employment of credible air and missile defense. In this situation, our adversaries are dynamically adapting to new technologies towards war waging in multiple domains. And it stands to reason that we cannot remain static in terms of technology. I'm happy to see a wide representation from the industry here today, and I'm looking forward to hearing them talk about their capabilities. The steady creep in our adversaries' edge in developing niche technologies in air and missile defense domain is aptly supported by a large industrial base, large-scale R&D, and excellent supply chain infrastructure. And this is where we need to head in the future. The rapid changes in technology underscores the requirement of constant modernization process to maintain a balance between obsolescence and niche technology. Therefore, there is a need that rather than play catch-up, it is essential that we stay on the ball and endeavor to remain ahead of the technology curve. On this front, India has been taking decisive strides in these aspects. Entry of a robust aerospace industry in defense has rejuvenated the infusion of niche technologies in this field. Almost all major components of our air defense sensors are being manufactured in high-tech facilities in the south. There has been a tsunami of SMEs who have stormed the counter-UAS industry space, and within a short period of just 3 to 4 years, one is just spoiled for the choices that have to be made amongst them. While Atmanirbharta campaign has altered the aerospace industrial capabilities, there are still certain critical components that need to be imported, and this is in context to what the Vice Chief and also our panel chair mentioned, that it cannot be at the cost of our national security. In order to realize the cutting-edge technologies in air and missile defense, the core areas where we need to focus our effort is as shown here. And to get us going forward in the right direction towards developing and imbibing the right technology for warfighting, some of the suggested measures are in terms of declare development of niche technology indigenously as a strategic activity. Better fusion of a defense industrial base with civilian technology and its industrial base. Focus on research in core and key technologies and collaborate with industry for indigenous development of the same. We need to identify mechanisms for civil-military fusion to encourage participation of domain expertise and academia to develop own capability to imbibe niche weapon sensor technologies. One of my personal asks is in terms of achievement of a faster OODA loop, equivalent in the life cycle of a problem statement transiting into a deliverable product that can be deployed in an operational environment. Build capacity to work in close partnership with private sector, DPSUs, DRDO, and academia in order to deliver cutting-edge capability to our forces through indigenization and innovation. We need to cultivate talent and blend military and civil expertise and knowledge. In conclusion, I would like to state that the forthcoming decade should target early realization of ongoing R&D into cutting-edge capability in air and missile defense systems. This would be in terms of better AD sensors, multiple object kill vehicles, electromagnetic railguns, space-based sensors, interceptors, and hypersonic defense and high-energy laser. In the end, the government, the user, and the innovation ecosystem need to work in synchronous and a synergized manner to achieve the same. Thank you.
Namaskar, Honorable ABM Saab and other speakers and distinguished audience and all the defense personnel. I'm Rajiv Mehrotra from Sham. You must have heard the name Sham Antenna and Telecom, etc. And what we are going to present today is about the standardization of the anti-drone systems. And as in the first session also, now also, the emphasis is on in the integration of all the sensors. If there is no standardization, they cannot be integrated. And it is actually a kind of a, what shall I say, piecemeal approach. So this is about us. We have been in the telecom since 1974, and we own all these technologies, what we are showing or what we have done in the past, whether it is satellite TV or cable TV or GSM and 4G, and sensors. perimeter intrusion, border intrusion, RF cyber, satellite transceivers. And we are part of these elite clubs where we own all these things, whether it is mobile intelligence or border and perimeter intrusion. Our philosophy is very simple. We do everything ourselves. We have no joint venture. We don't buy any technology, nothing. I have put in my own 1,400 crore rupees during last 20 years, out of which 700 crore has been audited by CAG, and that's why we have reached here. And what all we are showing is all cutting edge. Nothing like that exists anywhere in the world. Some of these systems have been done as industry partner with the premier technical research organization of Government of India. And we are not a system integrator. And why work with us? Because we own everything in the country. Everything stays here. We software, hardware, firmware, everything is ours, mechanical, nothing. We just buy only a camera module, which we very rarely use, except that everything is our own. And everything is standard-based, fully compliant labs we have. There is a saying, if you know how to test, then you know how to design. So first thing is you should know how to test it. And the money goes in testing is 100 times more than the cost of the product. And we provide lifetime support. So coming to the air defense thing, we are not in air defense system. We are talking of anti-drone system. What we have been told, or everybody knows, that up to 15 kilometer, above 15 is Air Force, below that is the local. Why this is not moving? What happened? Sorry. No. Sir, you will have to give me 2 more minutes. The technology. So this is who we are, and we are part of this club, as I mentioned, in terms of technology, and this is our philosophy, and why work with us. So these are our strong points, and air defense responsibility we have you all know this. We are talking of anti-drone system, which we think is only up to 3 kilometers, or beyond 3, it's a different technology then altogether. Then you go in air defense. So we are talking of this 3 kilometer. And working principles for any anti-drone system is you have to detect and deny and neutralize. And detect is through RF sensors, etc. But then there are some ratios, some specifications, what exactly we want to achieve, what exactly we mean by an anti-drone system, and what is going to be its use case. So this is, if the anti-drone system is located, of course, within the campus, what is the distance to the boundary wall, and then from boundary wall, for how far distance we want to detect and deny or neutralize the drone. And this ratio between the drone from operator to drone and drone to the anti-drone system is called the jamming ratio. It can be 5:1, 2:1, or 10:1, or 20:1. So this is how this is mentioned, location of the jamming, and it depends upon many factors. The type of drone one is using, and how far we are from there, how big is the area, where exactly it needs to be done. And once the 4 of these parameters are known, then you can design an anti-drone system depending upon the area you want to protect. So challenges are very simple: size, small signatures, range and altitude, radar, dead ground, audio. Audio is very much limited, academic thing only. Reaction time is very limited. Technical specification, number of frequency bands and RF power you need per frequency band, but that will depend upon how big is the area, where is the location of your anti-drone system, and how far from the boundary wall of the area which you want to protect, the distance between that and the drone. So this is simple: detect, identify, jamming, takeover. Takeover is something, this is very sexy. People want to, I mean, they have this desire, I want to take over the control of the drone. It doesn't serve any purpose. Something is coming from outside your boundary wall or from outside your IB. You just want to kill it. You don't want, I mean, what purpose will it solve? And if there are more than one or two, you cannot neutralize all of them simultaneously. It doesn't serve any purpose whatsoever. कि नहीं हम उसका forensic analysis करेंगे, किसने भेजा? That's a postmortem. किसने भेजा, कब भेजा, पर तब तक कांड हो जाएगा. उसको जो घेरना है वो घेर के चला जाएगा. लोग उसको एनालिसिस ही करते रहेंगे. Physical destruction, limited reaction time है, accuracy है, but small anti-drone remote weapon system kind of thing is possible. But for that, the user has to be very actively involved by mounting a 6-or on a pan-tilt platform. We have those platforms. We tested with AK-47. The range is limited 500 meters, but if you mount 4 of those 6-or, you get 700, 800 meters. So this becomes a radar-controlled gun. Very cost-effective, very simple, very easy to install, but on the boundary only. Coming to drone detection, so you have RF detectors, multi-band. They give you an idea. The accuracy, I mean the resolution or the sector they see is about 30, 45 degree or so. Drone detection radar, again, it is expensive, and the range can be up to 3 kilometers for small, those DJI drones. And another question comes, if somebody is flying a DJI drone from 3 kilometers away, what it will be carrying and how much he can carry and what that person, the operator, how he can navigate it. Network cameras, which you can put, they give you very good resolution, but then again during night is an issue. And another problem with this kind of camera detection is that during the morning or evening, depending upon the location on the IB, the adversary is also smart. So your camera is looking right into the sun rising or sun going down. You can't detect anything. So these are the issues. Acoustic is just an academic interest thing. Maybe in Europe, in some country, in Scandinavia, where there is very little noise, it may work. Soft measures, counter drone is radio frequency based jamming and protocol manipulation. On the jamming, it's a known thing, and that's the most effective. And obviously, it is also very cost effective. Protocol manipulation, that will take over the control of the protocols. The best, or let's say the best company who is doing this protocol manipulation or taking control of the drones, they guarantee only up to 65%, and with 65%, they don't say that. So even some foreign countries, foreign navies, they bought these anti-drone systems from Israel, and that they will take over the control, but they don't say which 65%. So this is not possible, and the person who is going to drop or who is going to launch a drone of this kind, just by manipulating one bit, you will not detect it. So it doesn't make sense. The Houthis or whatsoever is there in Shahid, there are other techniques. We are in the field, we know what is being done, what needs to be done, and how you can counter that. So these things, protocol manipulation, etc., is simply not there. What is extremely effective for Shahid is the jamming thing. How, that's a different topic. Kinetic measure, laser, yes, best, EMP, and anti-drone drones and anti-drone weapons. So smart jamming, as I said, that is the most effective and also cost effective, easy, simple to install and manage. Spoofing, RF cyber protocol manipulation, very difficult in a civilized work, like say, in when there is no war, when there is no issues, like in Europe, in US, yes, there it is very good. Because every drone over there has like a SIM card, they have an ID. So they can manipulate, they can change, they can take over the control. Not in our region, not in what is going on in Middle East. This is simply not possible. Counter drone system with a with a mesh or hitting a drone with a drone, again, it is good for US or Europe for display purpose, for presentation. In real life, has it any one of them has been ever used? we don't know. Remotely managed hard kill system, yes, this is easy. This is, you all know, this is like a radar-controlled gun, but in place of 30 mm, it is just a 7.62 and using a cost-effective 6-aught, and 4 of them mounted together. And then high-powered energy, laser and microwave. Microwave is the range is the issue, and but microwave in due course of time will become very effective for swarm, where no other thing will work but swarm, but directed energy, microwave energy. Laser, it is the best, but it has its own limitations. Known frequency bands which are used by commercial drones or the drones which are assembled by people across the border and others, these are 9 frequency bands. And if they add more, we should have the capability to add more modules in our system or upgrade them as and when needed in a week's time, not in months or others. Normal GPS and GNS frequency bands, which all needs to be mitigated. And there is, everybody, when it comes to jamming the GPS, they say they want very high power jammers for GPS and GNSS, 20 watt, 50 watt or something like that. No, that is not required. You just need 5 watt because the satellite is high up, the signal received by the GPS is very small, and then there are other GPS receivers. If there is a very high power, different signal is coming or a jamming signal, then they know this is a jamming signal, they discard this and maintain their route. So there is a intelligence built into that, and we don't have to transmit at such a high power, not even at the IB also. And of course, at Delhi airport, there were issues. So this will happen. If there is a warlike situation, what is happening in Israel, yes, there they are using, but they are using spoofing, a high power, not actually high power, it's a normal power spoofing system, so which misguides everybody. Drone communication and jamming, as I said, jamming ratio, jamming to signal ratio. I've given some details here. We can share this with you offline. Effective range, again, that depends upon the situation, the requirement, the threat perception. And we need 5 different types of anti-drone systems. For international border, there is a different type. For airports, is different. VIP offices, residential area, Luton's Delhi, or this area is different. Critical infrastructure, atomic plants, others, and VIP convoys. So this is for the IB. We need to put after every 3-4 kilometer a drone detection radar to ensure what all is coming from the other side, and it is not expensive. So
2 minutes.
Sorry, sir. Yes, sir.
If you can just.
This is just the kind of accuracy you get. This is for at the airport. At the airport, you put a very small range, 200, 300 meter drone detection radar on the boundary wall. For the campus, etc., this kind of system we are displaying outside. This is again for the vulnerable areas, for the airports, and what the specific deployment and what are the effects. Then there are we have consolidated some tenders and what kind of information they have asked in that. So these are myths. I need so much power, I need to be able to detect from 10 kilometer, 15 kilometer. This is not 10, 15 kilometer is not possible, neither realistic. And there are a lot of contrary things. So what we are exactly saying, there should be specifications and standardization for anti-drone systems so that people know what they need, and for 5 different applications. And based on that, systems can be designed. So this gives you a raster area. If it is 500 meter away, a drone, 0.1 meter accuracy means 0.1 degree accuracy means 1 meter by 1 meter square. The big thing is a drone gun, anti-drone gun. Now, everybody is crazy about these drone guns. They carry, how do you find in which direction you aim it? So that is the question. Who is going to communicate? Who is going to tell him? Or he has to listen. But there are systems. What all has been procured so far, except DRDO design, no specifications are there, except that it should do 5 kilometer, 10 kilometer. Ultimately, it is RF, it is the frequency and the power. So that needs to be measured and decided, number of frequency band, number of power, and how much it is affecting others. Our suggestion is to establish a small working group which can very quickly can come out with the specification and then standardize on that and the standard protocol so that XYZ departments are buying these anti-drone systems, they can be integrated into the bigger system and the test procedures must be defined. In terms of technology, who can help on these? Department of Telecom has a Telecom Engineering Center who deals in RF and microwave. I think they are the one who can be roped in to help on this.
May I wind up, please?
Sure, sir. This is, we have some other solutions for detecting pupil and foliage, etc. This is a secure broadband system on a backpack. This is outside, you can see it, and perimeter intrusion detection system, and a complete network of networks. Thank you, sir.
Respected Chair, AVM George Thomas, my fellow panelists, AVM Shivanand, and respected panelists from the industry, distinguished audience from the forces and from the industry and other things. With your permission, I will have my colleague, product manager, product engineering head, Sai Prasad, also to join me during the presentation. Thank you. Yes, please. So we are actually, we are more, slightly more on the cross-industry side. You are actually hearing about more on the cybersecurity where zero trust need to be imbibed. We are actually working with all the forces, and we have actually seen that this is one of those paramount thing which we need to address very clearly. Something from the attacks and other things which you have already heard by the respective distinguished speakers. But in this case, we are actually more touching upon the application side of it, where we can actually leverage the cryptographic identities of that. So we have actually heard about this buzzword called as zero trust, but we have actually done a ChatGPT and to check whether what is actually the zero trust means. And it always gives a very clear explanation that it need to never trust and always verify. And verify the users, verify the applications, and limit the access according to the trust. So that is what zero trust means, and that is what we are actually trying to do that as well. So what does attack surface look like in terms of the cyber defense is concerned? So there are employees in the defense forces. There are internal. We have actually come to know that there are internal threats also, and wherein definitely there are users, the access, and the APIs and the other devices, where your sensitive data is exposed via multiple channels to your customers and the vendors subjecting to the enterprise at the risk. The PKI public key infrastructure and digital certificates offer a very high level of security in transition to the passwordless and zero trust. Because this is what we are actually talking about, and the forces have actually taken a very clear note by introducing the public key infrastructure in their network, be it in the applications with the user devices and other things. So we work very closely with all the forces. So we are actually seeing that the threat is very real, and we have actually seen the SpaceX also have seen an outage in terms of they are actually being grounded because just because of an expired certificate, such a powerful mission has actually been brought down. So where actually our company eMudra fit in? So where you have actually seen that the fundamental part of the security system is the cryptographic keys. But the cryptographic keys, when we need to actually marry that cryptographic keys with those identities, that is the time when we actually create those digital certificates, and the digital certificate comes as a very powerful mechanism for handling all this stuff, where digital certificates and the keys combined together can be used very specifically in the authentication, encryption, and the signing use cases. This is very prevalent in all the applications which you currently use. You need to actually restrict the access by providing the authentication to the users in terms of it can be users and the applications very specifically, and also the data which at rest or at motion, you need to actually do the encryption technologies where your web servers or the other devices and the servers require those encryption, be it between the stations or commands where the data is actually moving. And finally into the signing piece of it, where you will be able to get a consent from a person to do that as well. So our products can actually help in doing, supporting with all these aspects where we clearly give the support for authentication, encryption and the signing use cases, and to manage the cryptographic identities. So our product stack actually span across multiple phases where we actually help the forces to have their own PKI setup, where we need to have the first to create the identities and also to marry and then manage the identities in terms of a certificate lifecycle management. And then you come to the authentication of that, where we'll have the identity and access management between the users and the applications, and when you can use the same concept for your signature signing solutions, where you can actually use the digital signatures for the person to mainly do it more for a paperless office process. So I would like to have Sai to come in and also explain a bit about the technology, how it can be used, and to confine with the time frame what we have.
Thank you, Biju. Good afternoon, everyone. This is Sai here. So without taking much of your time, I'll directly jump into the products that we offer in the market with respect to the public key infrastructure. So the core product which you are seeing on the screen is the EMCA, which is the core certificate manager, which has the capability of issuing various types of certificate. Because since morning we are hearing that there are so many hardware, like you have drones, then you have warfare systems, okay, which actually requires various types of certificates. It is not only X509 certificate that actually fits into those devices. There are other formats of certificate that also need to get used in those hardware devices. So that is done using this particular application. As you can see, it has the ability to issue user certificate, which we are currently, I think the Defense Forces are currently using it because we are working closely with them. Now, the time has come where the certificates need to be embedded onto these devices. So how it can be done? Using this particular software, which has the capability to issue not only to human but non-human, which includes your IoT devices, the devices in the 5G network. Everywhere you can deploy these certificates using our solution. Now, when you have too many certificates existing in the system, say now if I say when I put in zero trust network, so every human, non-human, when I say non-human, these are all devices. Now every device has to be issued a certificate. Now humanly it becomes difficult for you to manage those certificates which are existing on the devices. So how do you manage it automatically, or without human intervention, how you can actually rotate the certificate? So this is the platform which is called as Ernst, which is actually gaining a lot of traction not only in the defense but across other domains, where using this platform, an organization or an entity can seamlessly discover certificates that are actually hosted onto the web servers or onto the IoT devices or any equipment that the organization is using. Now, once the certificates are discovered, then using this platform, the organization actually gets a single pane view of all the certificates that are currently working within that network. And the platform also it does is, it is not only checks that whether there is an active certificate that is existing, it also does the vulnerability assessment of those certificates, because certificate can be issued with a weak key as well, right? So those parameters are also verified by this particular platform, and it gives a full report to the administrator or to the organization saying that, hey, there is a weak certificate that is available within the enterprise, so you have to take care of that. So that is vulnerability assessment part. Now, how do you actually rotate those certificates automatically? Okay, this is where the platform plays a vital role. So it has the mechanism where we have out-of-the-box integration with various devices, so using which we can do the auto rotation of certificates on those devices. And the platform also comes with inbuilt protocols, like as you can see on the screen, it supports KEP, CMP, EST. So if any of those devices support any of these protocols, then we can easily hook on or integrate those devices onto this platform and do the automatic rotation of certificate. Now, this platform only does the management of certificates, but from where do you get the certificates? So this is where again the platform has out-of-the-box connectors with the CAs. Indian Air Force is itself is a certifying authority chained up to CCA. So we can integrate this platform with that and use, get the certificates from that system and pass it on to the devices. And if there are any TLS or SSL certificate that is being used by IAF, even we can hook on to those TLS providers and allow issuance of certificates. So that's about the CertiNext platform. Then we have another product in the identity and access management. It's not ordinary product of just doing the managing the identity and then providing the access and also providing the authentication modules. It has AI inbuilt. So what we do is we do keystroke dynamics. We also have inbuilt machine learning models, which actually does the human behavior or the user behavioral analytics it does. And based on that, it actually does the step-up authentication or not allowing the user to log in to a specific resource. All that is done using this particular platform. Then we have, this is the top layer, where once you have the entire PKI ecosystem set up, you have a certificate platform that is available, certificate lifecycle management platform that is available to manage your certificate lifecycle. Then how do you use those certificates for signing a document? Or for that matter, how do you actually sensitively or securely store those documents within the doc store? So we being working in this field of public key infrastructure since 2008, so we have also made this application just not work as a workflow application, document workflow application. It also has the ability of secure storage of those documents and use the certificates which are valid, which are legally valid as per Indian IT Act, can be used on this platform to digitally sign the documents. So it's an end-to-end no paperless document management system that you can do using this platform. Yeah.
So just to touch upon that, where we have actually done all these things, it is not that not in theory. We have actually done it at a very large scale in the largest public sector bank in India and many of the other state-run organizations, smart cities, and also abroad. We have actually done in this way. We have identified almost like more than 20,000 connected devices to discover the certificates and do the key rotation and other things. The case study is actually on in Indian Army itself, where the identity and access management is actually being used. The USP is that we have used the public infrastructure to identify the SSO, and almost like more than 400 applications have been identified. And the complex workflow systems very specific to the defense forces has been inculcated into the applications as well. So moving along from that to the new age, new technology, what we are actually working into, Sai, you can actually touch upon that.
This is the, I think, the initiatives that eMudra has taken up in terms of the public key infrastructure, because we have seen since morning that officers have been stating about quantum computing, right? So that is going to be reality. So when that comes into picture, you need to also think about from the public key infrastructure perspective, because the current algos that is being used, okay, they will not be no longer relevance. They will not be relevant in the picture. So we are actually following the NIST standards. So NIST has actually come up with the post-quantum crypto algos, okay, which is up for standardization. Now out of the box, all our products which we have showcased just now, they actually support this post-quantum crypto algos, now using which the the organization can use this latest algorithms and start using it for signing, encryption, and all that you can do. Our solution out of the box supports these algos.
You have 2 minutes. You can
Yeah.
wind up.
Then comes the FHE, fully homomorphic encryption. This is very latest. Now what happens is when you are doing, you have stored the encrypted data, but when you are trying to do a computation on that data, you have to decrypt and do the computation and then encrypt it back. Now without exposing that data at the time of computation, so how do you do that? So this is the technology that we are currently working on. Okay, so we have done first phase of it. So it is fruitful. Now we are going to advance it so that it does work seamlessly. So this is about FHE. We are also working on the mobile PKI because you might have seen taken certificates either on token or your keys are stored remotely. Okay. Now everyone is using mobile phone. Why can't mobile turn as a token? Okay. And you store securely those key pair and use that certificate which is there on the mobile device, not only for authentication purpose, but also for signing documents, doing encryption of decryption of data, all that you can carry out using this mobile PKI. We have done this and we have a solution in place. Then we are also working because drones, all these things came up. I initially told that our solution supports various types of certificates. So we also our product supports lightweight certificates, which are called card verifiable certificate, which can directly embed into these devices and can be used for secure communication, passing signed data to one device to another device. So this also we provide out of the box from our product. And I think last slide, I pass it on to Biju.
Yeah, finally, to just introduce us, eMudra, we are working with the industry. We are the largest certification authority in India, have issued licensed directly by the Ministry of IT. And more than anything else, we are actually supporting all the forces. We have, our applications are actually being used in Indian Air Force, Army, Navy, to actually set up the PKI infrastructure for all the forces. Plus, we are also supplying all the identity and access management solution, end-to-end encryption solutions and all to the forces. Not only we are completely an Indian MNC, now also listed in the stock exchange. More than 800 employees headquartered in Bangalore, but also been a thought leader in driving a lot of other industry standards also. So thank you very much for a patient hearing.
Thank you. Thank you. I really thank the chair, AVM Thomas, and IMR Media for having me here. This is actually, just before I get into my talk, I'd really like to thank Major General Ravi Arora. It's not something that is commonly known, but when we started Big Bang Boom 6 years back, our first exposure to the defense ecosystem started with IMR Media events. In fact, it was at the 2018 edition of the Air and Missile Defense event that we had a chance conversation with Mr. Ajay Soni from Punj Lloyd, who told us, Shiva, stop looking at drones, start looking at anti-drone systems. That led us to build the anti-drone system that we are now supplying to the Indian Army and the Air Force. So we are really grateful for this opportunity, and I think it's apt that this opportunity, I'm able to stand here now to talk to you. It's very difficult to speak about a topic like this in front of such an august audience, especially after such eminent speakers have taken away a lot of the thunder. I'll try and put forward my perspective, where I think the ecosystem is and where I think it's heading. Currently, if you look at the drone threats today, the kind of threats that are there are quite varied, starting right from small drones from the DJIs, the FPVs, etc., right up to high altitude pseudo satellites. And each one of them have evolved, each kind of the drone that has evolved because of a particular requirement, a particular need. And it is also important for the counter drone strategy to also keep in line with what comes up here. So if you look at in typical how these threats are being countered, if you were to look at it we've already spoken quite a bit about the jamming, the UIR, the radar, the lasers, etc. But one of the critical things that we need to look at or think about is what is the real threat that we are going to be talking about? Is it still the DJI drones? Is it the FPV drones? If you look at the kind of threats that are there in the market today, we have the FPV systems that are coming in. We have the larger drones like the TB2 and the Shaheeds. Then you have the Lancet, smaller in size but more effective in terms of providing a loitering munition kind of impact. Now, the two major things, the two major buzzwords that we've been hearing a lot about is one, swarms, and swarms are a big threat. And we usually try to take a step back. We've tried to understand what swarms do, how is it that swarms basically engage or interact with various ecosystems, and we realize that swarms are typically made out of, let's say, 3 different distinctive kinds of swarms. Either they are centralized swarms, in which case countering them becomes very, very trivial. Swarms have a lot of communication going from the source to each of the drone systems that are there. Second are decentralized swarms that still have like a central node that's there, partially deconstructed or semi-autonomous swarms. Both of these technologies are actually quite effectively or most effectively countered by jamming technology. While it has the capability to overwhelm air defenses, it has capabilities to overwhelm even lasers, it's actually quite effective to counter drones using jamming. Unless the swarm drones are made intelligent or the swarm drones are made truly autonomous, where each node is independent of all the other systems that are there, can independently engage and complete a task. Now, that kind of onboard intelligence that needs to be put on top of a drone is very, very expensive. It comes at a significant SWaP-C constraint that is there as a part of it. So the minute you try to put intelligence, and we supply autonomous drones to the Indian Navy today, the minute you try to put an onboard computer, it drains the battery, that reduces the flight time, that reduces the payload carrying capacity, and it's very difficult for you to pick up a swarm that can do something like this. The minute you do it, is it possible? Definitely it's possible. The minute you do it, the RCS goes up. Once the RCS goes up, it becomes a lot easier to pick up the entire swarm, basis conventional radar systems, etc. The second threat that we are very cognizant about, and people keep talking to us about, are the FPV drones. The FPV drones are like shock troops. They're very good when you are not really expecting them. But if you are in there, you are expecting FPV drones to come at you, they're actually quite easy to counter. Primarily because they have 2 major red flags that come up. They have a very, very strong telemetry link, and they have a very strong video link because they are completely dependent on high resolution video to do the navigation. The issues with FPV drones are obviously the speed. They are much faster than most of the drones that we were used to, let's say, 2 years back, and that was one of the reasons it was surprised. But if you look at the counter drones technology that's available today, they have really adapted to this, and they've been able to come out with ways to counter the FPVs. In fact, using again traditional systems like jamming, spoofing, etc., quite effectively. So the thing that we would like to put forward, and the real threat as we look at it in today's ecosystem, is basically the threat of silent drones, RF silent drones, drones that I understand a lot of things that I'm not talking is not there on the slide. The slides are more like a placeholder. But the real threat that we like to talk about is the RF silent drones, drones that have 0 RF signature. They have absolutely no RF detection that can be done on it. Come with extremely low RCS, so you use asymmetric materials, like for example, we had shown Army yesterday drones that were made completely out of thermocol. 90% of the drone is made out of cardboard and thermocol, while being fitted with an AI or an intelligent module on top. These kind of drones that cannot be detected by your RF sensors, your radars, that becomes the real threat. Now the question is, how do you start countering them? And one of the best ways to counter, or the only ways to counter threats like that, would be increase the adaptability or increase the awareness of the hard kill countermeasures, and how is it that you will be able to take out. In the hard kill countermeasures, I think the critical part of it is lasers, one of the most attractive options that are there. Lasers are very, very effective. Costly, yes. Hard to maintain, extremely power hungry, absolutely not a doubt. But then they are also quite effective in being able to take out drones. Now, the issue again comes with the laser, saying that, okay, how do you counter, or how do you counter swarms of lasers, swarms of drones that are coming in? There, I think there's a lot of emphasis that's currently going on in electromagnetic pulse systems. Big Bang Boom itself has invested quite a bit into it, where we are looking at systems that are able to, at a very, very low cost, per pulse, like per attack at a very low cost, being able to take out a number of drones quite rapidly. The EMP systems currently focus on, let's say, 1 to 2 kilometers, 3 kilometers range that is there, and it looks at being a large AD system. But one of the things that we wanted to put forward, or we've been trying to ideate on, is trying to see if we can actually reduce the size of the EMP systems, bring it down to a form factor very similar to the drone jamming guns, to ensure that we don't look at being able to do EMP destruction or EMP countermeasures over, let's say, 3 kilometers. You look at equipping every unit with an EMP system, a system that can be maybe powered with fuel cell or be powered with just a very strong lithium polymer battery that are available today. It can shoot 2, maybe 4 pulses, but rapidly at around 50 to 100 meters distance and take out drones that are really coming in. That would be disastrously effective and extremely low cost when you're looking at countering a large number of small drones. To sort of build this out, we've been working on a new concept called RFSoC, radio frequency system on a chip. The radio frequency system on a chip basically gives a ubiquitous PCB board that comes with an inbuilt SDR, inbuilt power amplifier, and a scanner. That system on the chip is currently being designed by us to be less than 80 grams in weight, which basically means that it is stackable, it is scalable, it can be used to build small systems, it can also be used to build big systems. One of the major things that we are focusing on is the interoperability between all of this. There are companies that are making jammers, somebody else making spoofers, somebody else making radars. But if there is a core chip that actually is used by a large number of players, the interoperability and the interconnection between these systems becomes a lot more enabled and a lot more easier. So the RFSoC is like a lot of the effort that we are putting in is to be able to do that kind of a scalable version, where the user at his own need can determine whether he wants to use it as a detector or a jammer. He can use it as a short range detector at 400 meters, 2 kilometers, 5 kilometers, or do long range detection like the one that we have done with the Indian Army and the Air Force now, up to 15 kilometers of detection of DJI drones is something that's possible with the same SoC. We've also been able to do jamming with it. Till today, in field trials, we've achieved around 18 kilometers of jamming. We are expecting that the new systems that we are hoping to deliver will be able to beat that benchmark and pick it up from there. The other thing that we are keen, or other reason that we are very keen on, is what we call a beam steering jammer. One of the biggest disadvantages of using jamming based technologies is that, one, if you use an omni jammer, you jam everything out. It's great because you prevent frequency offing, but then you jam also your own systems that are there. It becomes very important when the entire landscape is dominated by a drone and there is a requirement for us to be able to operate our systems, even our drones, while being able to effectively take out the enemy drones on this thing. That basically gives us that asymmetric advantage the forces would be looking for. There, we think the potential is there for what is known as a beam steering jammer. You basically take the same tech that we are building radars out of today and try and see if you can pump in more energy into it. And instead of tracking a drone, you actually jam the drone using an ISA pulse. We've had limited success with it. We have done it till around 1 kilometers now. We are now trying to see if any of the forces would be interested in something like this. If that tech is of interest, we'll be more than happy to build it out. But we think it has a great strategic advantage in being able to single out drones that you want to take out. So you may imagine a scenario where there are 20 drones flying, 10 of them are your drones, 10 of them are coming in. Out of the 10 coming in, you only perceive 6 of them to be a threat. So you need the ability to take out 6, watch the other 4, and allow the other 10 of our drones to coexist in the same environment without having to affect all of that. And that is a capability that the beam steering jammer and the other new technologies that we are talking about will be able to give. Along with this, we've also built a prototype of a electromagnetic railgun, a small prototype. AVM Thomas, the chair, has actually had the opportunity to see this in our lab. It's a very small gun. It's primarily meant for attacks against conventional army use cases, but Sir was able to open our minds to its use case in air defenses also, where we're looking at magnetically accelerating a projectile without the use of any ammunition, etc., at speeds 5 times the speed of, let's say, a common AK-47 or a common gun that's there. So use the railgun technology, but not in large pieces, but actually miniaturize it and give it as a handheld system that can be effectively used to counter incoming drones that's there. This is again something that we have prototyped, and we end up doing a lot of this there. The other couple of things that we've been mulling over and we think there is importance for a community like this to think about is the ability of drones to start using options such as satellite communication through the Starlink network. This was effectively done in Ukraine. And one of the problems is that the Starlink already operates in 3 different bands, especially bands as high as 33 gigahertz. So there are no jammers available, there are no RF detectors available at those frequencies currently today. So if the drones were to, if your Shaheeds, if your TB2s were to start quickly using either Starlink or something equivalent, most of our countermeasures would fail because we are not ready to operate in those kind of environments. While the smaller drones, if you look at the latest Starlink Mini that has come, the latest Starlink Mini is 6 kgs in weight. If it's really required, somebody can put that on a drone. You put that on a drone, you don't have a countermeasure that's available today. So there is a need for us to expand the RF spectrum that we are scanning to really good ESM, electronic surveillance measures that we are taking, right starting from 1 to megahertz, right up to 30, 40 gigahertz. Build out the technology that we are doing, the same RF detection that we do very effectively from 70 to 6 gigahertz across the entire spectrum, and develop countermeasures that are able to navigate this ever-changing landscape. We expect that both the drone and the counter-drone space will keep evolving for the next 5-6 years, at least, before there is a sort of a balance that's achieved, similar to how guns and body armors keep evolving over time.
2 minutes.
I'm almost done. So I think that is very critical. And the last part of it, the last point that we like to put out there is basically the fact that there is also a need for us to integrate cyber warfare, or the ability for us to understand the cyber layer in drones and be able to start countering that. A lot of the countering today happens primarily on the telemetry or the control signals of the drones. And if we were to start understanding the cyber, which we have done limitedly to a couple of drones right now, where we understand not only what the drone is doing, where the drone is, but also what the intended purpose of the drone is, and etc. That would go a long way in us being able to devise very, very low cost but effective strategies for counter drone. With that, I'd like to wrap up my talk. Happy to take up any questions that are there. Thank you.